that program. I mean, it's not a big dog. This is more of my portable battery.
Just like fetch the somewhere else. But this is going to be handy because we can print out this and just have it in our hardware.
It's like, can I make it? Use the time
I mean, you've been working on, you developed half the crap I'm going to be talking about. I don't expect y'all to be here. It's fine. This is like the 5th time giving this talk. I don't need the moral support anymore. If you are here and you're expecting a talk that's about something other than ironic, it was canceled, and this is the new one. So just, you know.
I think it's syncs footage here.
We got about 3 minutes before it actually starts, but I'm going to say kind of my preface now. This is a 60-minute talk that I'm squishing into 30 minutes. The full version of this is on the G-Research Open Source Software YouTube channel, youtube.com/@oss-gr. That's not been updated for the last year like I did for this one. So, you know, if you're a person who likes to take pictures of the slides or detailed notes, don't panic when I start flying through it. All the information is there. And you can see a recording of a version given this, you know, recorded in my home. The other thing I'll note as sort of a preface before starting this is that nothing that's in this talk is special knowledge. This is just a parsed down version of the ironic docs. And my hope is to give y'all kind of a menu of things to go look up in our docs or to kind of ask yourself the question of, is this something that I need or that I want? Because I know Ironic has a really deep feature set that not everyone gets an opportunity to. So I'm actually going to start early since I've got a short one anyway. Most of you know me. I'm Jay Faulkner. I'm an OSS dev at G-Research Open Source Software. I've been working on Ironic for the vast majority of my career, over a decade. I host a Gross Out podcast. I've been doing OpenStack since 2014, and I'm a Gen 2 developer as well. So one of the things I'm going to be highlighting in this talk is the year that a feature was introduced, because I know that not everyone's going to be always running the latest version of the cloud. So just keep aware of this. You know, if you're like, oh, I didn't know that existed, just cross-reference it with the year your version comes from and see if it's actually there. Because Ironic's 10 years old, but I know that a lot of people might be running, oh, well, it's actually 11 years old now, but I know some of you might be running like, you know, a 6-year-old version of Ironic. And one of the things that's important to note is that many of the features I'm going to be talking about here require an Ironic API access to do it. So that means if you're using like a fully integrated OpenStack with Nova and you never ever call Ironic's API, or you have users that are never allowed to call Ironic's API directly, some of these features are going to be out of reach. Similarly, if you're using like Metal Cube with Ironic behind it, you might have to sort of pierce that veil and talk to Ironic directly. But one of the things we'll be covering is that Ironic now has tools and modeling to actually allow your end users some access to Ironic for information or maintenance of their hardware. So I'm going to quickly go over the basic architecture of Ironic, just so that, you know, if I toss a term out there, y'all aren't going crazy. So we have some sort of client, a user, API client, CLI, automation, whatever. It talks to an Ironic API service. That Ironic API service does very little except for, you know, basic database communication. Almost everything ends up going back to an Ironic conductor, and the Ironic conductor is what actually does the work. But how does that work actually happen? Well, you have the ironic conductor, which sort of interfaces with your servers or your nodes in a couple of different ways. One of them is via the IPA or Ironic Python Agent RAM disk, which performs actions in what we call in-band on the node. And this is literally just a Linux operating system that you can do it in Linux and Python. You can configure our agent to do it, even if you have to write a little bit of simple code to add to it yourself. And the other way, and sort of the prevalence of this in Ironic installations has gone up a lot over time, is this out-of-band interface with the BMC. That might be Redfish, that might be IPMI, that might be like something proprietary like your ILO or DRAC or something like that. But that allows you the ability to do things without having to boot an agent, and often can do some interesting, powerful things, but that's really where it starts mattering what hardware you're using, whether or not it's supported. So what hardware should you use? If you want a great, awesome experience with Ironic, you're going to want it used with servers with a fully featured BMC, and I would say fully featured would be good virtual media support, and a Redfish API. And I'll warn you that all Redfish is not created equal. It's one of those standards that's full of little tiny loopholes everywhere, and the hardware vendors find a new one every time they release a firmware version. So just have some awareness. I mean, quite frankly, if you're evaluating hardware, just search our bug tracker. Come ask a question or two in IRC and see if people respond with smiley faces or grimaces. And we're happy to help that way. But so how does Ironic manage talking to all these different types of servers, right? So we just talked about there's a bunch of different BMCs, there's different ways that conductors can talk, and that's our concept of hardware types, or colloquially, I call it a driver. And so the hardware type is a collection of interfaces for specific hardware. So, I said this is going to be like a menu of features. The hardware type is like a menu of things that a specific type or style of hardware can support. And it's a collection of interfaces, and we'll talk about what that means, because they're just pluggable implementations of our functionality, which can also be dependent on hardware capabilities for your use case. So this is not a comprehensive list by any means. It's just meant to sort of give you an idea of what's out there. Like, we have like a BIOS interface for updating BIOS settings. A lot of times that's using Redfish. We have boot interface where you can pick to boot machines using a traditional PXE, an iPXE, using a UEFI HTTP boot, using virtual media. And that's about how we get like our RAM disk or our tools booted onto the machine in the first place. We have console support. I don't have the example here, but we recently added graphical console support, even though that requires a little bit more operational work on your side to get working. Deploy, which is how we actually get the thing on the disk. I think when most people think about Ironic, they think about our default direct deploy driver, but we have lots of different ways to do that, and I'll talk about a few of them later. Firmware updates, inspection, and the inspector interface is actually gone, and I missed that in my slide updates. So, bye-bye inspector, we hardly knew ye. Management, which is like, what do I want to boot from the next time I power up? Do I want a PXE boot, or do I want to boot from the hard drive? You've got network for our integration with Neutron or NUB, and when we talk about standalone networking support, we're adding a network interface to support that. That's sort of the plug-in spot there. Power, RAID, rescue, storage, we've got all the stuff. But there's not just one thing for each hardware type. The hardware type can have an array of things. You can have a list of things that it supports. It's kind of obvious for some of them, like with the boot interface, it makes sense that you could PXE boot a machine that could also virtual media boot if that's what you wanted. And so don't always think of it as there being one thing. You pick a hardware type and then maybe you pick and choose what interface you want. So a concrete example of this would be the Redfish hardware type, which has multiple boot interfaces supported. Like I said, as an example, iPXE and Redfish Virtual Media. That's not the complete list. But also RAID interfaces. You have some hardware that can control RAID via an out-of-band interface, but some people are just using the agent to configure software RAID. So a lot of the Ironic features that are valuable, people think of it as a deployment mechanism, but server lifecycle is the stuff we care a lot about. And this is sort of the lowest common denominator. If you're running Ironic, you're going to be using some of these features. So first is node onboarding, which in 2015 we added a dedicated enrollment state where you can add the basic node information to Ironic, but basically have the conductor leave it alone until it's ready. Then you can do validation, which later on led to a feature we call verify steps, which allow us to sort of do some basic initial configuration to hardware or VMCs that maybe require a little bit of extra massaging before they'll be ready for us. And you can also get hardware onboarded via inspecting or even via discovering that. So what is inspection? Inspection uses whatever the interface tells it to to get information about the hardware. That sometimes is stored to a database, sometimes to a separate data store, and it's extremely customizable. And as of about a week ago, the repository is empty for the separate service. So the separate inspector service is gone. All the functionality has been rolled into Ironic. So I know there might be a little bit of a painful migration if you're already using it, but our hope and our goal is to lessen the complexity by reducing the amount of surfaces you have to deal with. This one less service, one less API surface, so it should make it easy. But we said life cycle. What is the life cycle of a node? And it's sort of a loop because it's constantly going. And so we're going to start out right here, because when you enroll, this is kind of where it enters. The node gets cleaned. Cleaning is the process we use where we get that machine to the same state every time. So when we deploy the operating system on it, we know it's going to be reliable because we've gotten the remnants of the old one away. So a node sort of follows this cycle of it cleans, it sits in our available state, which is sort of just it's in inventory waiting to be deployed. Then once you deploy it, you end up having a workload running that's in active state until it's undeployed. When you undeploy, it cleans again and it goes back to start. So you sort of get your nodes on this little life cycle. Obviously, this can be kind of painful when you go to EOL servers because you might want to like give them an exit ramp from the loop. And that's what node retirement does. It's meant to sort of, if you're a load balancer aware person, think of it as like a drain fail for a node, where you're saying it's okay that this machine is running a workload, but when it gets undeployed, leave it undeployed. Don't let someone else maintain it. So what happens is we just break the cycle. So when that machine gets undeployed, it ends up in manageable state instead of available state, which is sort of like the free parking of Ironic. You put the server there, you don't think about it, and it hangs out. And then you can use manual cleaning or other features to do some decommissioning work on that machine if you have special things you need to do before you retire it from your environment. So how is all this work arranged? It's arranged in steps. And steps are just the term we use in Ironic to describe a unit of work. Generally speaking, a step consists of a name, an interface it comes from, so you can mix and match a little bit. You can have cleaning, have some out-of-band stuff that maybe talks to your redfish, and some in-band stuff that uses the agent. A priority, which is used when you're using our automatic cleaning setup where we can detect hardware and pick what you want. And then some arguments, because if you're running a step and you're doing it explicitly or via a runbook, you might have arguments. Like for instance, we were just talking in the last session about the VMC time update. We recently, added the feature for that, and you got to tell it what time to set the server to, which we're going to make that magic, I think, sometime very soon, but it's a good example for this. What's important to note is that steps, while we have multiple different things that are organized in steps, not every step is applicable everywhere. So for instance, you're not going to have access to write image during cleaning because it doesn't make sense. We don't expose that as a deployment step. If you wanted to, you could customize it to do it, but we sort of try to make the things make sense out of the box for you. So what are the different types of steps you might see? Well, we're going to talk about the in-band versus out-of-band. With in-band, you're going to be using IPA Ramdis to perform tasks. It's really easy to add or customize steps. We have great examples sitting in the IPA repo that you can literally copy out to your external repo, use that as a basis for doing whatever you need to do. You will have to build your own Ramdisk if you do that instead of using the ones we publish. But that's really not difficult. We've done quite a bit to make that easy with the tooling. We also have out-of-band steps, which are using interactions with the VMC, that out-of-band interface to perform actions. And these are not as easy to customize. These are sort of things that we ship that are designed to work, that we've tested in hardware we know are safe on most hardware that uses that. Like a firmware update is a really great example of something that we use the out-of-band for. And there's kind of a third type of step that we added in 2023, which I sort of term a control flow step, which is one of those things that just lets you do things like explicitly power on or off or reboot a node, or maybe a child node, that allows you to just wait. If you know your hardware is broken in such a way that if you do a firmware update, Ironic, doesn't have a long wait, just put it in wait. Just have it wait. We also can have a way, and this is a really cool building block, I think, for operators that have to integrate with external systems. We actually have a way for you to just say hold, which is like hitting a pause button on whatever flow you're using until someone hits the API and tells it to keep going. So you can use different features to sort of trigger an event hold your machine, let that external service do whatever it needs to do, and then call back to Ironic and say unhold, and the machine can continue cleaning. And this gets really interesting when you start thinking about dependent hardware workflows, where you might have a server and a DPU that both have a DMC and have to do a little bit of communication to do things. You know, they can hold and unhold each other too. So some example built-in steps: we can erase your devices. We can update your firmware. We can apply new BIOS configuration. We have built-in burn-in support that you can run. You can build RAIDs, in-band or out-of-band. And like I said before, you can easily customize the step. We have lots of documentation for this. It's a little tricky because the docs are in the Ironic Python agent repository of documentation. So if you go look at Ironic for how to customize this, you might get a little lost. We should probably do a better job of cross-linking it. But look at the Ironic Python agent docs and it'll lay out this process. It really is dead simple. Even if you're not a Python expert, all you need to be able to do is an OS shell out and check the exit code if you want to run your local scripts or bash scripts or whatever. So we talked about steps. Steps are the building blocks, steps are the Legos, but you know, what do we use them for? How do we assemble them? Well, the first thing that was built, and this is actually a callback because when we had the Paris Summit in like 2014, I was talking about the alpha version of this feature that Rackspace had developed, which is automated cleaning. And this is what occurs by default when the node's deleted. That sort of that corner of the graph we saw where it was cleaning up between tenants. By default, what we're going to do is use the hardware managers to detect the hardware and run the steps that are necessary. That sounds really fancy, but in reality, it just erases your disks, maybe tears down or modifies your RAID depending on your configuration. But you can easily add steps to it, like we've said, using custom hardware manager, or if it's a step that we ship, that we don't enable in automated cleaning by default, we have configuration to allow you to override those priorities. Although I think that the use of that config is going to go down because new in 2025, we get rid of this limitation and we get rid of this obscure config file if you're willing to create a runbook, which is just a collection of steps that you pre-assembled. If you've ever done manual cleaning in Ironic, it's basically that API payload except for as an object in our database. And you can set up a runbook with explicit list of steps, the orders you want them to run in, and have your automated cleaning use that runbook instead of Ironic's implicit magic. Combining that with the node history stuff that was talked about earlier, where we're logging the steps that are run in node history for security conscious organizations that want to be able to have a strong attestation as to what happens between OS deployments, this is a really cool thing. But we also have some manual ways to do things. We have node servicing, which was added in 2024, and manual cleaning, which has been around a real long time, which is where you're passing a list of steps to execute on the node, or one of those runbooks that I talked about. Manual cleaning is designed for nodes that are not deployed at all, so they're in kind of that manageable, that little parking space, and then you can manual clean it, tell it to do what you want, direct it to perform a firmware update that maybe you wouldn't do automatically, whatever, goes back to manageable. But now we recently added the ability to do it to nodes that are already active. And so what that means is you can take that node that's active, Ironic will shut it down, boot up an agent on it, or use the out-of-band, although I don't really think it's possible to get it to boot 0 agents at this point. But I think we boot the agent once instead of twice. We got rid of one of the boots. And that'll allow you to do that service for deployed nodes. And when we talk about the RBAC stuff a little bit later, you can see how that might enable you to use runbooks plus servicing plus sort of this RBAC project identification in nodes to be able to give you can take a maintenance runbook and give it to your users and give them the ability to run it on their schedule. So the case I always think about with this is if you've got someone who runs a big data cluster and they really want to mark nodes as offline before they do a maintenance on them, you can give them the API access and let them handle that coordination if you're in a place that has sort of a platform engineering type of look. But steps can also be used in deploying, and under the hood, our direct deploy driver is using steps. And you can specify additional steps explicitly if you're deploying directly via Ironic. There are documented steps that in our direct driver are always included. We don't let you define using our default drivers, for instance, a deploy template that doesn't write an image out because it doesn't really make sense. And so we sort of take the deploy steps, we merge them into those required steps which are documented and go. But you can't do this through Nova. So if you want to do it through Nova, you have to use our deploy templates, which, similar to runbooks, you're taking a collection of steps, you're putting them into the deploy template, and we have hooks into Nova that allow you to adjust that based on traits, I think. Traits, traits tied up in the flavor for you. So I've already hinted at this too. We do have runbooks, automate the node cleaning and servicing. We match them up to nodes via traits so that you don't have to worry about your HP firmware update runbook being run on someone's Dell and causing the world to break. And like I said earlier, you can use that with automated cleaning now. So what about actual deployment? I've been talking about the direct deploy as our default. We have lots of ways to do deployment, and I think especially in a world where more people are using Ironic standalone or more people are using Ironic to deploy something like Kubernetes on top, some of these other deployment methods might be getting interesting for those use cases. But our default's the direct. This is what we used to call the agent driver, and it's dirt simple. We boot up that agent, we download an image, we write it to the disk. It's really easy to customize this deployment. Image deployments are standard in OpenStack if that's the path you're following, but you would be surprised how hard it is for new Ironic users to build a working image out of the box. Because you gotta think about a lot of stuff that you don't have to think of for VMs, like making sure your drivers are in shape, making sure your firmwares are in shape, and there's no support for custom partitioning at deploy time. You have to kind of bake that into the image beforehand. But we also can deploy a RAM disk. And this is sort of confusing because Ironic uses a RAM disk as a tool to do other things. But this is if you have a RAM disk and what you want is your node to be deployed with a RAM disk on it. And so this allows you to just, Ironic will take the image you give it, we boot it up on a RAM disk and we're done. It works really great if you were using sort of transitioning from HPC tools that are maybe based around a RAM disk ISO workflow. You don't even have to have working local storage. But again, if it's hard to get an image that you write to disk working, it's even harder to get a working RAM disk if you're not familiar with that. And there are definitely some limitations around how you can configure it with config drive depending on your hardware and your configuration. We also have an Anaconda deploy driver. The Anaconda deploy driver allows you to actually deploy sort of enterprise Linux systems that use Kickstart using Ironic. And we'll feed in a Kickstart and you get the full access to Kickstart. This is the easiest way to get custom partitioning in Ironic without doing a bunch of backflips. The weaknesses of that, it really does only work on enterprise Linux stuff. Quite frankly, it's not used by a large number of folks. So it's one of those things if you're using it on a new release of Alma or Rocky or maybe even CentOS 10, I'm not sure anyone's tested it on it. But it should work because it's Kickstart, and Kickstart tends to work across releases. And then the other one is sort of, I've talked about we have guardrails up on our normal deployment where we don't let you do silly things. These are our let you do silly things drivers. We have an Ansible, which literally is going to boot an agent and use Ansible playbooks to run a deployment on the node. And then we have custom agent, which is the exact same as the direct deploy interface, except for you get no steps for free. So if you're the person who wants to do a deployment without running a right image, because you have a weird use case that I would be really interested to hear about, then you can use custom agent and just have to do static deploy steps or use deploy templates to do it all. This is fully customizable, but nothing interesting works out of the box. I think our Ansible driver is set up where it'll do a basic image deploy, but if that's all you're doing, use IPA and direct instead. So how do you actually do deployment in standalone if you don't have Nova? Well, you have to make quite a few API calls. You've got to set up some metadata and instance info with the image information capabilities, config drive. You have to do some calls to Neutron if you're using it. You have to call an Ironic Provision State API to deploy. This is a really rough interface, honestly. It wasn't really designed for users, but we did a couple things to try to make it easier. The first is an allocations API, and this is an API that you can call and describe general attributes of a node you want, and it'll sort of reserve it for you by creating an allocation and adding an instance UUID to the node, which is sort of like making the reservation at the table so that you can then have time to make those API calls that you need to set up the metadata before you deploy. And those allocations do get removed explicitly after an undeploy. This is also the reason Metalsmith existed, but Metalsmith's gone now. So that is sad, but I don't think there's anyone around to mourn it because not many folks were using it anymore. There's also Bifrost, which is an install and deployment tool for standalone Ironic. It's Ansible with a better UI on top. And a lot of people can use this to like sort of one-shot deploy servers. You don't necessarily have to use Ironic as a constantly running service. You can use something like Bifrost on a USB key on a laptop plugged into a couple racks of servers and push out a bunch of images to them and just be done if that's what you want to do. You can also deploy in Metal 3, but I don't follow that Lovecraftian Kubernetes stuff. So there's separate talks about that. You can go follow up on that. So some tools for Ironic operation, and this is sort of if you're the operator, what do you need to do? We got 10 minutes left, so I'm going to fly through this. We've got conductor groups. Conductor groups are a way for you to indicate to Ironic that you want this specific set of Ironic conductors to manage this specific set of nodes. A lot of people use this for maybe separating security zones out to make sure that you don't have traffic crossing a security zone. To make sure that some people will use it to follow the model of their data center. So maybe they have a conductor group that represents a computer room or row or something like that, so you've got some locality there. And this can also be used to horizontally scale other services that talk to Ironic, although we have a more preferred way to do it now. And quite frankly, if you have questions about scaling using conductor groups and sharding, we just landed a doc which explains this way better than I could in a talk. Just look up the availability zone doc in Ironic where we sort of talk about how you can use conductor groups and node sharding to emulate availability zones in Ironic. And sharding is similar to conductor groups. That's a way to chop up nodes, but it doesn't actually affect Ironic's operation. It doesn't exclude anything Ironic does. This is just a flag that lets you do things. So let's say you have to make an API call for every node you have. You have 10,000 nodes in your environment. You could assign, 10 different shards across all of those, and then you could run 10 jobs in parallel limited to that shard. And that's basically what it exists for, except for Nova. Nova is one of those examples. A Nova compute service is generally designed to scale to about as many instances as would fit on a single hypervisor. A single Ironic installation can manage tens of thousands. I've even been in one that managed over 100,000 nodes. So obviously, a single Nova compute's not going to do that. You would have to do sharding to cut that up into little bitty pieces. Like I said, how to do that's well documented. We also have graceful shutdown now, which is nice. It took us way too long to get this, but you can use SIGTERM and SIGUSER2 to sort of control things as you shut them down. If you want truly no impact shutdowns, this can give it to you. If you set the timeouts high enough, you send the signals, it'll let the conductor finish everything it's doing without picking up new work, which is pretty cool. We also got node history. Node history was added in 2022 as sort of a database-based log for events that happen to the node. So one of the things that we used to always have is sometimes we would have an issue like, say there was an error deploying, and then that node would be undeployed, and then there's an error undeploying. We used to clobber that first error in that case, but now they're all going to be in node history. You can go look. And it's not just useful for troubleshooting a single node, but you can also query this in aggregate to sort of get an idea of failure patterns across your servers to see if you have things wrong. And like I said earlier, step-based workflows are now adding that audit information about what steps ran into the node history for you. There's also notifications. This is an OpenStack-wide thing, notifications. So if this sounds cool to you, it's probably supported in other OpenStack services you use. But basically, on events, we can send a notification to your message bus or to your log. That even supports Kafka, not just Rabbit. And then you can trigger other things off of this. So if you sort of think about this feature combined with the holds that you can do in cleaning, that's where you sort of get those raw material tools for better external integration. Because something can listen for a notification that the machine was held, take the action you want, and then unhold it. So again, sort of Legos that you can build up to make it do whatever workflow you need. And Ironic also supports adoption, which is a way to add servers to Ironic that already have an OS installed that you don't want to wipe the OS yet, but maybe when it's undeployed you do want it wiped. This is only officially supported for standalone Ironic, and so I certainly would never encourage you to go read our unofficial documentation on how to make it work with Nova, because Nova would not like that because it's not supported, but it's well documented. It's a good choice for migrating your environments. So we focused on the operator bit, And now we're going to talk about tools for end users. And this is sort of where we've added in that bit where maybe if you're doing a platform for other technical people, maybe it's time to give them a little bit of access to Ironic in addition to the other OpenStack services. That's because we're not just an admin API anymore. You can assign a node to a project via owner or lessee. An owner is meant to be like the permanent node owner. So like it would stay for the lifetime of a node. The lessee is more meant to indicate who's on this instance right now. So that those are configured separately. They have separate RBAC, and we have a pretty good default policy around this. But obviously, as in OpenStack, you can customize that to allow an owner or a lessee as much access as you want. We have some tools around that, like you can turn on an option that would allow a project scoped manager to create their own nodes in Ironic, as with them as the node owner. You can have lessee set automatically on deployment, whether it be via standalone Ironic or via Nova. We can set that lessee and it gets cleared when the instance is cleared off of the machine. And we also have that sort of tooling. You can combine it together to end up with a single Ironic cluster that might serve multiple different pools of hardware or multiple different teams inside, sort of getting that bare metal as a service without having to have a bunch of OpenStack with it. So what's next for Ironic? Some of this is you. Last session we talked about the fact that PTG starts a week from Monday. And if there's something here, if you're going, why doesn't Ironic do X, or why doesn't it try this approach? The PTG is the best place to engage with us and ask that and help you determine what's next for Ironic. And that's because our best feature is the community. When this was written last year, we had over 600 unique contributors in the Ironic repo alone. This isn't counting IPA, this isn't counting anything else. And so we want you to be in the community. You know, if you've got a use case that we don't handle, if you want to figure out how to implement one of these features, and maybe my promise that the docs were up to date was hopeful. You know, come ask us. We're happy to help you. And honestly, if you just want to come tell us your hardware horror stories in IRC, we will commiserate with you and try to one-up you. And those are the most fun conversations to have. And you can find us at OpenStack Ironic on OFTC or on the mailing list. Got 2 minutes left if you have any questions. If you do want to see the long version of this talk, you can go to the GR Open Source Software YouTube channel. We also have the Gross Out podcast, where we've been running it for over a year, where we're interviewing different people in the open source community. And because I'm me and I'm the host, a lot of them are OpenStack related topics. So just have a listen if you sort of have a hankering for that hallway track conversation when you're not at the conference. And of course, G Research is hiring in London. You can go apply there. And generally, there's a lot of cool events and stuff going on. So if you're in the UK or know people in the UK and you want to see what's going on, just hit up our website. There's always interesting talks and stuff. Specifically, Gross Out Podcast, I have an interview with Fungi and Clark B, which was really fun talking about OpenStack. What you got, Julia?
Since you made this deck, we added yet another deploy interface, Bootc.
Oh, that's right! Yeah, so we actually have the ability now to boot this sounds crazy, like I felt insane when this was pitched, but there is actually a tool now which can take a specially crafted container and deploy that container onto bare metal. Not as a container, but it takes the contents of the container and puts it on bare metal. That uses Bootc. Other things that we added along those lines that weren't here, we support OCI image support. So if you're using standalone Ironic, you don't have to use HTTP, you don't have to use Glance, you can use your pre-existing image registry. I will note that's a new feature, so there are probably edges, especially if you're using some sort of repository that's not one of the big ones that we probably tested against, but we'd love to fix it if there's a problem. But I mean, there's a minute left if someone has a quick question. Otherwise, I'll be here at the conference, and like I said, I'm always on IRC, happy to help y'all out. But this was useful. Thank you. Give me 1 second. Yeah. said, that's a 60-minute talk. It wasn't 60 minutes this time, so what you need? Oh, thank you.